Hello everyone. Here we were studying about assemblers. So in today's session we can see about design specification of an assembler. So we have already seen language processing. It will involve analysis of a source program and it will involve synthesis of a machine code program, or we can say that as a target program. So here there are some steps to develop a design specification. Like, first of all, we are supposed to identify the information which we will require to perform the task. Then we can design suitable data structure to record the information. Determine processing necessary to obtain and maintain the information. After that, we can determine the processing which is required to perform that task. So here we can see one example. So we will get how the data structure of assembler. As you guys aware about the mnemonic, this is nothing but when we are using the instructions, you can say that as a mnemonic opcode. After that, here we are giving a length to that, how much it can store. So here you can see when we are studying about the fundamental of language processing, at that time language processing involves two programs. These are nothing but source and the target program. You can see here the source program, it is nothing but which we are giving to the analysis page, and after that synthesis of that program means what? Target program will get synthesized at the output. So you can see here, if we are using here mnemonic like add sub, at that time we can use here one syntax, because when we are saying about the source language, that is when we are writing any program in the C language, what we are supposed to follow the syntax. Means if we are supposed to write a program like addition, we can write here x equal to y plus 3, but we can't write that like x equal to y plus star 3, because when we are supposed to write the program, you are supposed to follow the syntax, and for addition, subtraction, multiplication, whatever the syntax, we are supposed to use that only. So here we can see about the synthesis and the analysis phase. So synthesis, if we are using some instructions like mover, break, one, to synthesize a machine instruction, we will require address of a memory word with which name 1 is associated. If we are taking one example like mover, break, comma 1. So here we can say 1 is nothing but it is address of memory word with which 1 is associated. And here we are using the mnemonic opcode, that is nothing but a mover. So address depends on a source program, so it is made available by the analysis phase. Operation code depends on assembly language, so synthesis phase can determine it. And synthesis phase, it will use two data structure, symbol table and the mnemonic table. Symbol table which will contain the name and the address. Mnemonic, which table will has two primary field. These are nothing but mnemonic and its opcode, like mover and a break. These tables are used to find the machine address with which name is associated. So here we can see assemblers. When we want to do analysis of a source program. At that time, that will isolate label, mnemonic opcode and the operand field of the given statement. And if that label is present, enter pair. It means we can write in bracket that symbol lower than, greater than, in between we are supposed to write the LC content. And in a new entry of a symbol table. After that we will check validity of a mnemonic opcode through a lookup in mnemonic table. And after that we can perform LC processing, that is update the value contained in LC by considering opcode and operand of a statement. And here after that in the synthesis phase we will get machine opcode that will corresponding to the mnemonic from the mnemonic table, and the symbol table which will synthesize a machine instruction or a machine from a machine form of constant. So here you can see pass structure of a assembler. Pass of language processor is one complete scan of a program, or it is a equivalent representation. So if you see here we will get two pass transition or one pass translation. Means here one pass translation as well as a two pass translation we can use. So you can see pass 1, pass 2, that we are saying intermediate in between these two. We can directly control transfer. We can do the control. So when we are designing a two pass assembler, at that time we are supposed to separate symbol, mnemonic opcode and operand field in a pass 1. After that we can build symbol table, perform LC processing. It means what? Location counter processing. Construct intermediate representation. And in pass 2 we are supposed to synthesize the target program. Pass 1 will perform analysis of a source program and the synthesis of intermediate code. And pass 2 processes intermediate representation of a synthesized target program. So you can see here when we are supposed to use data structure and file into pass assembler, at that time OP code table, opcode table, symbol table, literal table. At the output you will get the analysis phase, that is nothing but a target program. And here in the input side at the we are giving the source program, or you can say that is a analysis phase. So you will get at the end of pass 2, that will be the program which will listing with or a listing without error. So when we are saying about the pass 1 of assembler, it will uses optab, simtab and littab. Optab, a table of mnemonic opcode and which will related with the information. Like opcode means it is related with the information. Simtab, that is which will related with the symbols. Littab, which will give us a table, that is nothing but a table of literals which we can use in the program. Optab, which will contain mnemonic code, class information, where you will get class which will give us whether opcode corresponds to imperative statement, declaration statement or a assembler directives. And for imperative mnemonic, information contains machine opcode and instruction length is it contains ID of a routine to handle the declaration of a directive statement. So you can see here some examples, like we can use mnemonic, or you can say mnemonic opcode, that is mover class is. Means what? Which class we are using here. You can see here. Imperative statement or a declaration statement or a assembler directive. So you can see in the given table. Here we can use different symbol also. We can use the pull tab. you can see about the lid tab here. So you can see one example when we are using some instruction like a mnemonic opcode mult, which will do the multiplication, sub that will do the subtraction. When we are giving the add, it means what? Here we can add, means first operand is modified, condition code is set. Like that we can do here the functions. So you can see here some examples. When we are moving, position get changed, you can see here.